me now online as well and a little bit better in the room. So welcome to the user group, or already 69th user group here in Switzerland. And what we're going to do today is first we're going to record the session as usually so that people can watch it online on YouTube as well afterwards. And I go start with what's new in Power BI. I will skip for this time the Fabric announcements. For those who know, we have in Vegas right now a conference. During the conference, quite a lot of new features has been announced, but as it is still going on, I will wait for the next time to go through all these announcements, just that you know. So we're really going to focus on Power BI this time. Afterwards, we go more into the end-to-end scenario for the hands-on workshop that you did during the day, for those who've been here in person, and really highlight and go deep dive into the single elements. And obviously, if you have questions, feel free to raise them. I hear somewhere my voice here. I will need to check. Yeah, okay, whatever. All right, let's start. What's new in Power BI? Again, I always start with that slide. We have as well a conference in Europe. The one right now happening in Vegas will happen more or less in September as well here in Europe, in Vienna. It's in September. I'm not sure if you already can register. Haven't checked it. I think it's open now, but not 100% sure. So for those who want to attend, feel free to check it out. Register yourself. And during the Vienna conference, we will also do some Fabric announcements and like in Vegas, more or less. All right, then we have a grace period. This is very important to know. Roman talked a little bit about it. If you have Power BI Premium, you would need to go to Microsoft Fabric at some point in time, a little bit depending on your contract and so on. But nevertheless, at some point in time, you would need to migrate. And what we offer on one hand is a grace period for 90 days, meaning within 90 days, you can have like Power BI Premium and Fabric at the same time. You won't be charged for Premium in this case, so that you have enough time to migrate your workloads from Premium to Fabric. What is here important, if you wish to migrate, you can always reach out to us. Microsoft is, because we have a service called Cloud Migration Factory. It's free of charge for you as a customer, where the CMF, the Cloud Migration Factory, will do the work for you. So if you're interested in migrating, really just feel free to reach out to us. We nominate you, then the CMF team will align with you. They have the scripts, they have everything ready. You align on a date, they do the work for you, test it out, everything that worked perfectly fine. In some edge cases, not everything can be migrated. This is something that you would need to do either on your own or together with us again, like me, a cloud solution architect or whoever. But I would say 90% of the things work through CMF. And just that you know, Roman over here, he's especially the guy to talk to because he's in lead for P2F migrations. Is that right? Perfect. Anything to add? Perfect. Questions? All right. Then what we announced is annotations in PowerPoint, meaning if you embed a visual, not a report, but a visual within Power BI through this live embed mechanism, you can now add an annotation by right-clicking on a data point, add an annotation, and the annotation itself will be saved in the add-in of the PowerPoint. So it will not be saved somehow in the Power BI service. You won't see it in Power BI service. It's really just within the PowerPoint that you add those annotations. Yeah. Questions? Doesn't look like it. All right. Some not my proudest moment, but still to mention. Power BI desktop improvements. It's faster now to load. Honestly, I haven't recognized it until I read it. But it looks like it's really a little bit faster now to load. Just wanted to highlight that because we did a blog post. But I think what is more important is the second bullet point here. The 32-bit version will not be supported anymore after 1st of July. So make sure to upgrade or to use the 64-bit version. Okay? Questions? I don't think so. All right. For those who are working with Copilots, we are also enhancing Copilot over time. In this case, I wanted to highlight three things especially. One is if you're using Copilot to create DAX statements, it's getting better as you now also recognize user-created hierarchies and folders. So you can really mention as well those things to Copilot and it will understand. The next thing is that the question that you ask will be also better understood by Copilot. It will automatically use some kind of synonyms, even if you do not provide it specifically in the semantic model. It will take some out-of-the-box synonyms to work with your data and provide a better answer. So the key message here is it's improving. And the last thing, this is, I think, a nice one. You can also do ad hoc calculations now, meaning you can ask really Copilot, like in this case, you see, how has the average unit price changed from February to March? And it will automatically calculate February minus March, or the other way around in this case, and show me the difference. So even if this measure or this column is not within my semantic model, it will create the necessary DAX. And you can always go to expand answer, and then you will see the two tabs here at the top. And if you go to DAX query, you will see exactly the DAX query that has been written to calculate what you asked for. Quite a nice handy feature. Any questions to that? All right. One thing that I didn't put into my slide, but just to highlight, Copilot until now was only available for an F64 or above. But we announced that Copilot is now available on every F2 capacity starting from 1st of May, right? Yeah, end of April, 1st of May. Meaning even if you have an F2, you can now really use Copilot as well and start exploring it. Just that you know. Questions? All right. One handy thing, especially if you're a developer, you can now copy object names in your Power BI report. This was especially frustrating for those who have Git integration, working with Visual Studio Code, whatever. If you go and check out the visuals, the visual object name, the technical name is always some kind of GUID. And it was a little bit hard to know, okay, which GUID is exactly which visual. After a while, you get used to it, and obviously you know then which one it was. But now there is a setting. If you go to options and setting, report settings, you can enable report objects. And if you do that and right click then on an object, you can copy the object name. And then it's much easier. You can go into your Git repo, for example, search for it, and you exactly know which visual, which unique ID it is. And the same works as well in Power BI Service. So in Power BI Service, here's as well under the settings on the report, under settings, a report object setting which you can configure to copy that. Questions? All right, looks like everything is super clear. One of the last things, create direct lake storage mode now out of the box with Power BI Desktop. Until now, it was the case that you need to create first a semantic model in the service in Direct Lake, and then you can open up Power BI Desktop and connect to it and edit it. Now you can really start from scratch in Power BI Desktop, go to one lake hub, connect to whatever, warehouse, lakehouse, whatever supports Direct Lake at the end, and then you create automatically a semantic model within the desktop, which is stored in a workspace of your choice. And this way you created a semantic model out of Power BI Desktop, automatically stored in the workspace as mentioned, and you still edit it in desktop, and everything that you edit is automatically also saved then in the service. Just a little bit, yeah, easy ups the life for those who are working with the Direct Lake storage mode. Questions to that? Okay. Then we have use notebooks. For those who have Microsoft Fabric enabled, it's a quite handy feature because in a lot of cases I got asked like, how can I improve my model? What can I do to make it faster and so on? Or how can I get some metrics out of it? And there are ways, always like, for example, if you're working with DAX Studio or whatever. And we now implemented 3 out of the box buttons where you can just click on it. For example, the best practice analyzer. And if you do so behind the scene, a notebook will be published and created. And if I'm not wrong, even a lakehouse where the data will be stored automatically into it. And through the best practice analyzer, this is let's say an open library, if you wish, which checks your semantic model based on best practices and gives you recommendation what you can do to improve it. For example, writing better DAX measures, I don't know, have a look into relationships if is it necessary to have a many-to-many relationship, unused columns or whatever. And with that, it's really out of the box, takes, let's say, a minute, it will be populated, and you will have those insights already available then. Make sense? Questions? Yes, please. Only who can create Fabric items, because you need to be able to create these notebooks. So you need to have this permission. And obviously, a Fabric capacity of workspace assigned to the Fabric capacity. So those things still applies. But if you meet these requirements, then everyone. Yeah. So the field parameters are missing in the web UI. Until now, you had this workaround of connecting them through the desktop and create a field parameter in desktop. That would work. And this is still true. So it works technically, but in the UI, it's still missing. So you need to go through the desktop. And now it's just easier and faster to create it at the end. Any other question? Oh, sure. All right. I think this is really my last one. Org apps enhancements. I need to go back away from my laptop because I hear myself. For those who are working with apps, this is like an enhancement of it. We call it organizational apps, in which you can not only add Power BI items, but as well Fabric items, like a notebook, for example. And this is the way to go. Looking and talking with the product group, we are now more focusing to enhance org apps in this case. Meaning if you're using Power BI apps to distribute reports, I would start thinking of switching to org apps, because this is one of the biggest feature I would say that we have now compared to usual apps. It's Git enabled, so you can integrate it with Git. And in the deployment pipeline process, you can also integrate it to deploy now org apps. So updating it automatically. I think this is one of the, let's say, bigger issues working with apps. When you try to automate it, there is not all REST API calls are there to do so. And I think with org apps, we now solve this issue from my point of view. Questions? Okay. All right, then let's start with the end-to-end scenario. Meinrad will join us as well just in 15 minutes, more or less. But until then, let me give you a little bit of again, a little overview, especially for those who joined online. And I realized I need to switch my PowerPoint slide right here. All right. So how did we start? Why has this idea, how was it born, this idea? And a while ago, I went to Meinrad, like, I want to store some data and visualize it, especially stock data, as privately I'm interested in investments and stuff. And I know in Microsoft, we have like a bunch of different kind of storages, meaning I can store it in SQL, I can store it in an Azure Data Lake, I can store it in the Lakehouse, and where not. What is the best approach for me to store my data? And he was like, from where do you get the data? And I was like, yeah, I have a notebook. I'm calling a REST API call. At that point in time, now it's a library. But at the end, I have a notebook to get it. And I know once I store the data, I know how to work with Power BI to visualize it. But this middle thing is what I'm not so sure about. And he was like, you know what? You're not the only one who has this issue. Let's come together and build a solution, trying to have a best practice end-to-end solution where we go through each item and try to implement it as best practice as possible. And then we can use that and share it not only internally with Microsoft is, because even we in Microsoft have the same issue at the end, but as well sharing with partners and customers. And so we can really all together work on it. And that's what I meant in the morning. If you see something, really tell us, because we want to have this as a best practice end-to-end scenario if somehow possible. And from this simple question, we realized that we have quite a few requirements. On one hand, we want obviously to have it a fast and flexible solution. And for that, we decided to go with an event house. As in most cases, working with IoT data and stock data is nothing else than IoT data. It's just a question of how often you get it. On a daily base, on a minute base, on a second base, it's IoT data at the end. And that's the reason why we decided to store it into Event House, as it's IoT data. And we decided specifically to store our dimensions into a lakehouse, just also to show that we can combine those things together. To simplify things, we could also go just with an event house, but as mentioned, we want to really build an end-to-end solution and showcasing as well the power of Fabric, how we can integrate different things together. The next thing is, we want obviously to regularly refresh the data. So I'm not there every day to push a button to refresh my data. I want to do that automatically. And for this thing, the best in our case is a Fabric pipeline. I mean, yes, I can also trigger just a notebook, schedule one single notebook, schedule the other notebook, schedule a semantic refresh, and so on and so on. But obviously, I want to orchestrate that in a more easier way. And that's the reason why we decided to go with a notebook. And not only that, we also want to have it metadata driven, meaning I just want to, if I wish to have a new stock item or to delete a stock item, I want one single place to do so and not searching through different items. Where do I need to update it? And this is also very handy then with the pipeline in this case. And to store this meta information for myself, we need SQL Server database. On one hand, to have this meta table where we have this, as mentioned, like the watermark. So when was the last time that we get the stock data, which stock data, and so on. And additionally, we decided to have this log information. As mentioned, log is automatically there with Microsoft Fabric, but just for the last 30 days. So if you need a history, you need to take care of and save it somewhere. And in our case, we do so by saving it into a SQL database. And obviously, once we have the data, we need to somehow visualize it. This is Power BI report. So we connect to it and show it more or less near real time. And we are also experimenting a little bit with real-time dashboards. That's the reason why we put it in brackets, next release, to see where it makes sense to have a real-time dashboard and where it makes sense to have Power BI report in this case. And lastly, this is also on our, let's call it backlog. We want to have Fabric activator. It's not data activator anymore. I need to update it. Fabric activator, in case something unusual happens, I want to get notified automatically. So for example, if a stock price drops by 10% or increases by 10% or whatever, I want to get a notification. And this is also something that we think of implementing into our next release. Make sense so far? Any questions? So the end result, it could look like this. So in our case, we have Apple, Google, and Microsoft. In your case, you played around with Microsoft and UBS at the beginning, and then afterwards you could implement NVIDIA, Apple, and Google, I think, is what we added. So this is how it would look like, the first page and the second page. And if I just quickly go back, on our first page at the top, we have the stocker price at the end, and below we have the volume just to see how much it's traded. And we see, for example, that Apple gets much more traded than Microsoft for whatever reason. And on the second page, we see percentage changes. So even if the price probably is lower from Google than compared to, let's say, Microsoft in this case, it doesn't mean that with Microsoft you make more or less money, because it's more important on percentage how much it grows. And that's the reason why we showed percentage change over time and the absolute change as well. And this can, from stock information point of view, can be more helpful, because in a stock world, you don't talk usually about absolute changes, you talk about percentage changes. Right. And important side note, just going to repeat that, especially for those who joined online. We have this built as a reference use case for us, as mentioned, from end to end, following best practices wherever possible, from what we know. And there are 2-3 things which we specifically decided to do it in this way. And one is we used what we say human readable keys. So in this case, we use the tickers, so the symbol like Google, Microsoft, or whatever, as a key. In a production environment, you would most likely use a surrogate key here, because it would be faster to join and better to store and so on. In our case, we decided against it. It would be just a little bit of an overhead at the end, as it's not that important with just a few records. I mean, we have, in my case, I have like 80,000 records or something. There is no big difference if I have a surrogate key or just a text key in this case. The next thing, and this is even more important, is transmitting JSON to the event house. Meinrad explained it already a little bit in the afternoon, but in a real world scenario, we get in an IoT case, most likely a JSON, which we take and have to unpack and have to transform. Oh, sorry. And in our case, if you follow the notebook from GitHub, the notebook call to get the ticker data is at the end a pandas data frame, so it's a table. And we take this table and create a JSON out of it to store it into an event house and create a table out of it. So it's a little bit an overhead, yes, but we specifically decided to do so because, as mentioned, in a real world scenario, usually you have JSON, and we wanted to show how we would treat JSON. And with an event house, it's quite easy. We will show that again and a little bit more in detail. It's quite easy to take this JSON, unpack it, and have it in a table format. And lastly, reporting is limited to Power BI right now. We will explore, as mentioned, real-time dashboarding as well. So the solution, I know people in the room heard it, but for those online again, for the solution, we wanted to leverage Microsoft Fabric as much as possible, so to not use any outside service in this case. And we started with the engineering, so with notebooks to get the data, so the company data, like company name and address and stuff, as well as the ticker data. And we use Data Factory to wrap it into a pipeline to run it at the end. And then at the beginning, we used an Azure SQL database as the Fabric database wasn't available. Nowadays, we use a Fabric database to store especially 2 things. One is the meta information, so which ticker I want to get, and to store as well the log information. So every time it runs, that I can log it, is it successful or did it fail? Why did it fail? Even with a link to the notebook that I can really check out what has happened. In the database itself, we have as well store procedures, which we are calling from the pipeline. The store procedures are responsible to fill in the log information, for example, or to get the tickers and so on. So the idea of the store procedures is to have the logic for the pipeline outside of the pipeline, so that the pipeline just calls it and the store procedure does the logic. And it's then easier to change the logic if needed. So I do not need to touch the pipeline in theory. I just need to update the store procedure and the logic will apply. The next thing, once we have the data either for stocks, or in this case for stocks, we store it. In this case, we store it, as mentioned, as a JSON format into our event house. And from there, we connect with Power BI and displays as we see here on the screen. The company data, so the dimension, we store it into a lakehouse. Perfect timing. We store it into a lakehouse, and we created a shortcut from the lakehouse to the event house. And in the event house, we take it as a bronze layer and make a silver and gold layer in the lakehouse. And what we do on top is we have a slowly changing dimension logic implemented, meaning if something changes, we check that in the event house and track it, store it, and always have then the full history of what has changed by for our company. But obviously, the gold layer gives us the current state. But nevertheless, I can go back in time and see what has changed, if an address change or industry or whatever. On top, we see an arrow going down, meaning in the event house itself, on either on the database or on a table level, you have the possibility of activating a feature to write automatically everything or every data that comes into this database or table into the lakehouse. This is done automatically, and it's free of charge. You will not get paid additionally for this storage, which is quite nice, because with an event house, as good as it is, obviously it also has limits. And one of those is if you need to read more than 500,000 records, more or less, you get the limit. There are, some a little bit workarounds, let's say, to increase that, but this is more or less the limit. And working with machine learning, data science, probably you need more, and then it makes sense to store the data into a lakehouse and get it from there. And that's the reason why we activated this, let's call it continuous export to the lakehouse. And lastly, we schedule it, so meaning it runs every day. The Python library itself just gets on a daily basis the price information, and for our case, it's absolutely fine, as I'm not really interested on a day trading or minute trading. I just want to have it on a daily basis, so that's perfectly fine. But obviously, if you need something more real time, either you could decrease this frequency of the job to run it more frequently, or, and this is also something that we think of implementing in a second release, instead of using a pipeline to push the data into event house, to use an event stream. So feeding the event stream, and the event stream feeds the event house. This is then like the next step of our evolution, let's say. Any questions for that or so far? I think it's quite clear as you worked with it during the day. I don't see any questions online neither. Let me just open up chat. Okay. All right, then let me move on. Let's deep dive really into the single elements and start at the top with the database. And I'm super happy to see Meinrad because I will hand over for that to you.
Okay, welcome back. And I believe we can start here with that metadata database. And the idea is on one side to have the data which steers the process coming from there, and on the other side also to maintain the state for which stock we already got the data for today, that we don't do twice the same loading again. And the other more important point of view is I really hated to write code within the pipelines. You have a crazy editor. It's extremely hard to debug. And if you have to use this, implement the same logic twice, you duplicate the code. And if you say, well, the logic which steers the pipeline is encapsulated in that database, then you do a stored procedure call. We see it already, getting the list of stocks. We have two pipelines. The first one, which is getting the ticker data, and the second one, which is fetching the metadata. All this information is coming from the same place, implemented once, which makes it much more efficient to develop and to debug. And if we take a look, we have on one side the transfer object table with the information what we would like to transfer, with an overview about what was the status, was the last call successful or did we have an error end, and what is the high water mark, what is the latest date that we have in our database, which means you can also create a Power BI report just on top of that metadata. These are the stocks we are fetching. This is the status that we had. This is the high water mark. We have up to here the data. And then the very detailed log where each execution is logged with the information when it started, how many records have been transferred, and was it successful or not. And we already explained that in the morning that we have the functionality to say we start getting the data, we load it up to now, some point in time where we start. If we have been successful, then we move the watermark to say, okay, the next time we kick in at this point in time. And if something fails, that we can just keep the watermark where it is. The next day or the next retry will then restart again from that point and probably load in the next run a wider window because we are at the next day. And as soon as also this data transfer was successfully, we are in sync. And the idea is that we should be normally really in sync, that all stocks could be fetched at the same time, but we run then independent, and if one fails, it fails. We still get the other ones. If we have just these daily numbers, it's in quote simple. If you think, well, we are getting second values, something like that, then in most cases where I'm working with the customer, they say, well, I would like to get them up to a point in time. I start with the first one now, with the second one a little bit later, which means for the second one, I could theoretically get more data, but I say, now I'm starting, please fetch all data streams up to that point in time, that we have a consistent view up to which point we loaded data. And this is also implemented here in that pattern. And it is simple to implement. Start the transfer, tell the metadata database if we have been successfully or not, which means can we move the watermark to the next point. That's all you have to do. And if you take a quick look, we get that get ticker list. And if you look at it in detail, the get ticker list provides also this upper end, which has the same point in time for all stocks. And this is that logic that if we start a transfer, everything is loaded up to that point in time. Then we call start transfer and either successful or stop. And here it is, that's what I mentioned. If you do the call here, you can see this upper point in time is identical for all the stocks. That's the reason we defined that. We said, okay, we would like to have the feature. If you say, no, I would like for every one the latest point in time, then you can just change the logic here and say, I don't rely on this one, I rely on now. And then if you look at the complexity of the stored procedure, it's close to trivial. You go in and say, okay, please give me for this object, this UTC date time, there we log when we started. And if we have been able to successfully complete, then we do the update statement where we say, okay, now it's time to move that watermark for that stock, and everything else is, or there's nothing more to do. Then if we take a look into how we bring data in, we saw that we have our JSON, that we have to move it into tables using the update policies, and then remove the duplicates, because these platforms just guarantee that we get each record at least once. And the beauty of KQL is, or one of the beauties, that it is really simple to crack such JSON messages. Most of the time, if I develop cracking, I say, okay, go to that ingest table where data is coming in and just pick one row. Because most of the time you have somewhere an array, and that one row will generate hundreds or whatever of data points if you transform it into a table. And if you already start with 50 rows, then you don't get an overview if the system really behaves correctly. If you say, okay, I take the first message, then I can see what is stored in the database. My recommendation is store just in one column the whole JSON message that you got. If you are fetching data from an event hub, then you have also telemetry from the event hub when the message arrived on the event hub and stuff like that. Then you can easily add them here because they will always arrive. But I wouldn't recommend that you already split the message, because if you split it, then your splitting process relies on a shape. And with this approach, I get a JSON. As long as it is a valid JSON, I can store it. I can then do the next steps. If we take a look at the structure, we can see that we have the main node here and the data node. If we tell via KQL, well, please unpack that column, then the result is a column, data, and main. If you then unpack that main, then you will see that you have additional columns coming from here: API, pipeline run ID, stock market symbol, and timestamp. The pipeline run ID is also coming from the pipeline. It is fed into the notebook of Christian, and Christian gives me that information, which means in my telemetry data, I can tell you which pipeline run brought in this amount of telemetry data. Then we expand this data, because here we don't have just attributes below it, it's an array of messages. And now you can see then suddenly from that one row that I had at the beginning, now I have these 5 rows. And if you don't start with that take one at the beginning, you cannot really control if what you are doing is what you should do. Then we unpack each of these rows, and with that we get the additional attributes: close value, date, dividends, high value, low value, open value, and so on, and the volume. And now the last thing that we have to do is to translate the Unix encoded date and timestamp attribute into value timestamp, fetch timestamp. And we decided that we would like to transform the stock split in a string attribute, because we are not really sure what is coming there. And with this, you have already the correct data types. You can take this function for each message that is coming in. For that reason, we encapsulate that code in a function. And if we call that function, then this unpacking happens, and I have to remove that take one, because we can get more than one rows then if really the transformation should happen. And with the last statement, lovely policy, where I say, dear system, if something arrives here, please run that code for the new arrived records and bring it to the next level. And with that, we have created an ETL job. and as soon as a new data set is coming, it is transformed, stored in the silver layer. And then I said you have to get rid of duplicate records. And in our case, we said if we get for the same stock, for the same point in time, multiple records, then take the latest one that we got. That's one approach. If you are not sure if the values have changed, if you are really sure that if I get the same data point twice, the values are identical, it is really somewhere on the chain a data duplication, then there's also function take any, which runs faster because then the system, as soon as that one, can give it out. And that's fine. And with this, we have solved that problem. And now I will find, Christian, I will find power if you explain that slide. I have it here. I have one here.
It's kind of.
I have it.
Okay, thanks. All right, and with the Python code to get the data, and there are always different kind of steps that you need to follow. For those who not so familiar with Python, we can work with so-called libraries. Libraries is like a package that you can just reuse. So you do not have to code everything from scratch on your own. You just reuse the work of others and calling functions which gives you those, or which are out of the box available with the library then. And in this case, we, on one hand, use the Yahoo Finance library. This is not touch. Ja, da, also normalerweise ist der da, aber ist aus. Siehst du? Da können wir nachher so schnell schauen. And what we have as well are some supporting libraries like pandas to transform stuff, like JSON, and so on and so on. So this is the first step. Next, we define parameters, and those parameters we want that that from outside of the notebooks they are accessible and we can overwrite them. And within a notebook, each cell we can define if the cell is parameterized. And to do so, we can go to the three dots and say toggle parameter cell. And if we do that, we can call those exactly those parameters outside, in this case from a pipeline, and overwrite the default values. Because what you see here, these are the default values, meaning if I do not provide another value, this one will be taken. And in the pipeline itself, we see, for example, here the last one, start date, and we take it from the activity start transfer, the output first row, meaning it's a dynamic approach. The start transfer executes a store procedure. It gets the date that we want. We take this date and provide it to the notebook. Next, we have some, let's say, logic. What we find out during the process is if you run a full history for one company like Microsoft and fetching like 50 years of data into one JSON file, it's a little bit too large to store it into one row. That's the reason why we had to split it up into years. So we go for each company for each year and fetching the data that we're looking for. That's the reason why you see here a 4-year in stock years. And what we do further is, you have to imagine if you're running for the first time from the beginning of time, let's say, we have to go in and make sure that during this runtime that we go from the 1st of January start year until end of December start year. And then going into the next year and again updating it. But if we are in the current year that we want to run, we do not overwrite the start and end year. We're just taking the current date that we need. And then afterwards, we just go in and say, okay, please give me now the stock details. The history, it's quite simple. In here, we really filter it down to the current start and end year in which we are in during this loop. And if something happens, we just skip it. So it means, for example, if I say for Microsoft start in 1900, it will skip the first 80 something years because Microsoft was not listed during that time on stocks, so it has to skip it in this case. Or obviously, if something else happened, if you have an error message or whatever, there are better ways to handle those for sure. But in our case, as it's really just a simple use case, we wanted to skip and go to the next year and try it again. But if there is no error, it will go in and prepare the data frame to store those data at the end. And preparing the data frame means we have here at the top defined column names, which we are looking for. This is our empty data frame, and we put every year into this final data frame and appending it more and more to have it at the end, one complete data frame. Yeah. Then, as mentioned, we use then the data frame and convert it to a JSON, as we usually in a real life world work with JSON. This is the reason why we have a structure for it. We have this main, what we saw previously from Meinrad, in which we put in the meta information. And this is also a nice way because I do not need to provide the meta information on every row. I just provide it once at the top. And because of this unpack functionality with Custo, it will take over on every row afterwards all this meta information. And I provide my stock details over here. And to easy up my life with notebooks within Fabric, usually you work with Spark data frames, not with Pandas data frames. That's the reason why I just convert it quickly. And then I save it into Custo. These are just the options that you have to provide, like which Custo URL, which database, which table, and you have to give an access token, and the access token is called over here, just to make sure that you have the right permission to do so. And one highlight here for us was we do not need to create any kind of service principal, any kind of Azure Key Vault to store any kind of credentials. This is it what we have. Point. So we didn't talk about security at all because there is no need to give some kind of permission or whatever. We are in Fabric. And because it will run on my behalf or on a managed environment, more or less, it will automatically be able to connect to the Custo database in this case, which is really, really nice. And lastly, we have an exit parameter, which we provide, meaning if we run the pipeline, once the notebook has succeeded, we want to know how many rows has been implemented or has been added to the event house. And that's the reason why we do a count at the end and provide it as an exit parameter, which we reuse within the pipeline for our log table. So we can go in and check out, hey, yes, you run probably successfully, but perhaps you have just 0 rows in there, and then we can check out what happens. Or we can also see it runs and it has 10 rows or whatever. A little bit of logging mechanism. And I think this is again your part, right? Okay. Any questions so far? Or yeah, let's make a quick break here. Okay. We do have oh yeah, the question was if we have something out of the box when it comes to monitoring, and can you just connect to the database, let's say? Yes and no at the same time. Yes, we have some monitoring capabilities out of the box, and I can show that quickly just live. On the left-hand side here, over here, you have this monitor hub where you can see everything that you do within Fabric, if it succeeded or has it failed. And you see we worked on it, so it failed sometimes. But nevertheless, you have it here. one of the biggest issues is we store the data for 30 days, meaning if you need a real history for, I don't know, years or whatever, you have to take care of. And there is no way that I'm aware of that you can really just export this monitoring in a simple way. So you need to create it somehow on your own. But the good thing is, because you're creating on your own, you can define of what you're gonna log, what you're gonna store. And this is one of the reasons why we created our own log table. Anything to add there, or? Yeah. No. Yes. Yes. There is no, as far as I know, for monitoring, no way to increase that, right? Right. Yeah. On a capacity level, you have the possibility of having the Microsoft Fabric capacity metrics app. The metrics app gives you insights of the jobs, how much capacity units has been consumed. But you will also see if a job failed or succeeded, but that's it. You don't know why. In the monitoring hub, you have the possibility of hyperlinks, going really into the job, see what happened, and having a better description. But the metrics app gives you more an overview of how much usage of the capacity has happened. This is the idea. But there again, the metrics app gives you 14 days of data. And if you need more, you also need to take care of on your own. And there are different ways to do so. Any other question?
So sometimes the glass is half full or half empty. And in my opinion, it's at least half full, because you get automatically the last 30 days with the execution pipelines. You can see how the pipeline looked at the point in time, what was executed, what was the result of that execution. So up to that point in time, you have the very, very detailed information. And there are tools out there where you can grab the information and store it in your own database. But the infrastructure, at some point in time, it will cost money. And we said, okay, we keep in the standard fee the 31 days. Most of the time, that's good enough to really monitor. We have a problem. What is the issue? If you believe you should keep it longer, there's the API to grab it. There's a KQL database where you can put in and then analyze the data at your own. And there are GitHub repos where you can set up easily that process.
There is one good thing talking about Git repos. We have a Git repo called Fabric Tools. And within Fabric Tools, you have multiple folders. And one of those is dedicated for administration and governance. And I just checked it out yesterday, and it's really, really nice, because you have an out-of-the-box solution which you can deploy, leveraging notebooks to store this information more or less automatically. And you do not need to take care of it from beginning and writing your own script. You just can leverage this Fabric tool GitHub repo, just that you know.
Yes. And the poor man's extension is that table here. And if you put it in a SQL database, if not all of your processes are in Fabric, you can also feed that table which processes that are sitting around, which gives you the view, and you can delete that data when you believe it is time to delete it. Now coming back to the lower road, and there we said we try to be lazy and implement that path as simple as possible, which mean per definition our lakehouse here is just a bronze layer. The bronze layer mean you can get the data, overwrite what you had yesterday, and that's it. So the complexity of that notebook is extremely simple. Get it, overwrite the company info, done. The next step is then tell the KQL database there's new data. Please add that new data to your table. And there we control if something changed. If something changed, we add the new record to that table. which means we have for the same company duplicate records, which is a standard problem of a KQL database. If you find multiple records, please give me the last one. And that's the current situation of the company. And the first table, the silver table, has all the entries. With that, we have the slowly changing dimension implemented. And with the materialized view, get just the last event, we have the golden record that we then can use in the Power BI report to present the data. And for that reason, the logic is extremely simple. We just feed the data into one lake. We create a shortcut within the KQL database to that record. Then from the pipeline, we say, please append to your silver company table what is coming out from that function. In the function, we build the hash on the relevant attributes from the table, from the data that is coming in from down here. We do the same for the data that we already have in the table. And if something changed, then it is either a totally new row or a row where we had an update. Then please give it back. And with the function set or append, the output of that function, we have implemented slowly changing dimension type 2 on that table. And I believe the golden one, removing, just showing the last one, is not in the PowerPoint, but it's the same thing. Go to the table, do an argmax on the timestamp, and we are done. And then, as we said, we mirror down the data. And in my opinion, you usually have to handle there a dilemma that you get telemetry events, and in many cases the telemetry events are quite small. And you would like to see in a dashboard, in a real-time dashboard, each event as soon as it is coming in. On the other side, our lovely OneLake with Delta Parquet, an optimal file size is 256 megabyte to a gigabyte. Now, if you just work with Delta Parquet, you have three options. Option one is I wait until I have 256 megabyte of telemetry data, and then I write the file, which means it can take hours until you see the new data. Or you say, well, I have a time window in it. After 5 seconds, I write. Then you have thousands of files, which makes the platform inefficient. And then you have to implement a job which takes these tiny files and aggregates it together. Or you can go that approach where we say, well, we have a database which is optimized for real-time ingestion. There we see each record as soon as it is there. If we have enough data, then we write it down in the lake with file size which makes sense. We have also a time bomb that after a few hours we write, but then you end probably in 3 files per day, which is also not a problem to handle. But you don't have to reorganize the data at any point in time. But the consequence is that here you see the latest and greatest, and here you see all historical data. And that this is written also in the documentation, this adaptive behavior, which will try to make this data estate as efficient as possible right from the beginning. If you are looking at other implementations, you have really this vacuum job, compressed job, where you always have to take care on your data lake that you create. And here, then the consequence, this endpoint to do the analytical work. The default limit is 500,000 rows or 64 megabyte for the output of a query. And if it is a report, this is some 100 pages. If it is a diagram, you cannot see the data points on the screen because they are just too dense. So for interactive analysis, I never had an issue with that limit. And the reason why the limit is there, the KQL database can grow to petabytes. We can only handle petabytes if we have in the background multiple servers dealing with part of that data. If we execute the query, we are connected to one node. That one node gives then the backend node the work to do, and the result set has to flow through my node where I'm connected to. And if I have petabyte of data and my query will fetch a petabyte of data, then this node will get overloaded. It doesn't make sense. It's not built for that purpose. On the other side, if we have the petabyte in one lake, and if we start a Spark notebook, if we deal with that massive amount of data, then also my Spark cluster will be created with multiple compute nodes in the background. Each of them can go to one lake and fetch some of the files in parallel. We don't have one head node sitting in between, and there you can implement then also this query in an efficient way. And so massive data, we can get it from there. And also if we replicate the data, this data set is then available for all other users of the platform. If I have somewhere a warehouse with some data and I would like to join this table with data coming from the event stream, I can do it on one lake. It is a data set with tables with record in our unified store. And now it's getting quickly complicated, but we start with KQL, which makes it quite simple. We have to bring the data from the KQL database to Power BI, and we already saw in my small demo how simple it is to do the first analytical steps. Usually after having that gold stock with just one record for one data point, the logic again starts a little bit from the business perspective, because the end user would like to do some kind of calculation on top of this data. For example, what was the growth? And the growth is I take today's value and take a look what was the value of yesterday, and the delta in between is the growth. And here the language again is shining. I can say, okay, order please by symbol and value timestamp. And if I would like to find out what was the last close, I can just say previous close. You can do similar things with SQL, but there it is blah, 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 blah. And it's as simple as that. I sort my data and I'm looking for the last one. And that's exactly what you write with KQL. And then the gain is take what I have, take the close of today and subtract the last close, and then we have it. And percent in that way and round it that way. Then it's just simple. But you don't want to have that logic in each report, which means you create also functions on top of the data where you have some central logic encapsulated in a function, and then from Power BI you can just ask KQL, please give me gold stock with all the extended calculations we added, which mean the logic is the same. We write the code, we encapsulate it in a function, and then Power BI can use it. We have there what we saw also this morning, very, very good support to fill missing gaps with serious fill backward, constant forward, or linear. And these are just a few functions that the engine provides. And now I believe we finally end up how to bring the stuff together.
Thank you. And yeah, now we have this whole run of getting the data, preparing the data, and now it's really about visualizing the data. And in our case, we work with 3 tables. One is the fact table, meaning the stocker prices. Then we have a company dimension, meaning that we know the company, the industry, and so on. We connected, obviously, the fact and the dimension. And on top, we added the company timestamp so that I know which was the last run of each company as a meta information within my report. So I can do that on top as well. And we see below, we have the 3 tables, each with those connected with each other through a one-to-many relationship at the end. What we have as well is helper tables. So we are working in a direct query mode, and we want to provide from a slicer selection. So if I select here, for example, the window size, so do I wish to have 1 day, 1 year, 10 years of data? This should be provided into my KQL statement to my function at the end that I just get this kind of data and nothing else. And in Power BI, this is called dynamic M parameter. And to be able to do that, I need what I call a helper table. So what I did is I really just created hard-coded, in this case, the window size and the bin size. And the date is a calculated table, meaning I check which is the first date that I have, generally speaking, in my data set, and which is the last date. And between those 2 dates, please create me a date table. And that's what I do over here. And what we have then is on the window size, we created a slicer for the bin size as well. And there is one thing which is not so good solved with Power BI. If you're working with a dynamic M parameter and you have a date, the slicer is a date. I cannot change it to a between or to have a nice hierarchy or whatever. It's a date. And this is a nightmare if I have 10 years of data. So I have 3,650 kind of selections. And this is the reason why we decided to go with year, month, and then I can select the date. So the idea is to really select first the year, then I select the month, and due to that, we selected to a maximum of 31 selection points in the date slicer, just that you know. And to help a little bit and user-friendly, over here, we have a DAX function checking if you have chosen something else than you could be possible from the selection before. It gets red and it says, hey, please select a date. That's what it does. And to look a little bit behind the scene, this is in Power Query at the end. Once we connect to the event house, we use the Azure Data Explorer connector, meaning we don't have a specific event house connector because it's absolutely the same. And in here, we provide obviously the Kusto URI URL as well as which function we want to call. And on top, we provide some sample data at the beginning just to be able to connect to it. And this is the function that Meinrad just showed, which we call from Power BI. In the next step, I parameterize everything. So in Power Query, I create the parameters, obviously. Call it whatever you wish. In our case, quite obvious, the Kusto, DB, window size, and so on and so on. And then in the advanced option of the Power Query, I go in and update the hard-coded values with my parameters. So for those who work with Power BI, parameterizing, for example, the data source, nothing fancy, nothing new, absolutely the same here as well to parameterize the stuff. Once parameterized, I think this is not on this slide. Yeah, once parameterized, I load the data and connect it with my helper table. I can show that. I think it's on the next slide, not on the next. Yeah, I will show that as well. But before I do so, there is one thing which is important when you work with dimensions, because this is how we did it with the fact table, which is perfectly fine. But with dimensions, there is a little bit of a difference because you need to mark it as such. And I see my slide is the other way around as I thought, so sorry for that. So once I load from the fact table the parameters, this is the way how to bind it. So we close and apply, we go to the relationship view or the model view, we select the field on which we want to bind the parameter that we have created before. And in the property section, you have here bind to parameter, select it, and this is it. So this is really the bin size. This is the name of a parameter from Power Query. And then you can use this field in Power BI as a slicer, and everything that you select there will be automatically provided to Power Query and provided back to Custo. All right. And now coming to the dimension table. From a principle, it's absolutely the same, meaning I parameterize everything and so on, but there is this one big difference. Because it is a dimension, I specify it as such, where I say is dimension equals true. And the reason is at the end, performance from Custo. Because if Custo has two tables and you specify nothing, it tries to join it afterwards because that's what we do. But if you specify this one as dimension, this is the smaller one, it will process it and take the smaller table as a filter statement for my fact table. And therefore, my result will be faster there as I'm filtering out first what I need and then I process and calculate. And if I do something or say something wrong, just correct me. Yeah.
It's partially wrong. Who knows what Custo is? KQL is quite close. It's just one of the names that we have for ADX, for Event House. Internally, it was called Custo. Exactly. And the starting point is Jacques Cousteau, the deep sea diver who was looking for new things down in the sea. And that's the reason why KQL is called KQL. It's the Cousteau query language. And we have sometimes problems. We say Cousteau or ADX or Event House. It's all the same. It's good. Maybe you can show it, the parameter selection. And when you show it, I can explain a little bit the ID behind it. So with this approach, we can fill the time window with today, because that's what you usually would like to see. The latest N information. We can discuss about how far back the drawing should go, but if you go in, most of the time you would like to see it up to now. And with this approach to say we feed the function the upper end of that window, this can be easily implemented. Then we can say you can read that window size at that bin size. The bin size means should the system show me really the data point it has, or do an aggregation at 5 minutes, 15 minutes, 2 days, n days. And with this construct that we say, okay, we specify the window size and the deepness of the information, we know in our example, we have daily numbers. It's not a problem. We can show all the 20 years. We don't hit that 500 data point limit. But if you have second values, it really matters. And then you can say, well, I control in my function. If the window is tiny, I give really the data points that I have. So the
Now you should be better. Thanks for that. And then to show that if I go to my bin size column under advanced, this is the parameter binding. So you see I choose bin size. And this is really if I go to transform data at the top, manage parameters, I am binding it to this specific parameter. And the parameter itself, if I open up my fact table, advanced, you see here, this is really the bin size that I am providing at the end, which goes back then into my KQL statement, into my fact table. This is how it works at the end.
And it is extremely fast. And if you would like to present IoT telemetry data, you would like to show the latest data point, you have to go direct query. So, the data that is coming to Event House is replicated with one lake mirror as soon as the system has a certain amount of data, which mean in direct lake, you probably see data from 3 hours ago. The only point where we really have the latest and greatest is the Event House.
As direct lake is not supported in the Event House itself. It's direct query that we connect to the Event House, right? And direct lake would need to have it in the one lake in the lake house or in a warehouse. Yeah, that's the thing. Yes, that's the thing. All right. And this is what I meant, that if you select a date or that doesn't really work, you see here, please select a specific date. This is the DAC statement behind that makes sure at least I have a hint that I need to reselect my date. Okay, it's your turn.
Now explaining exactly what we are doing with the missing data points a little bit more in detail, and that time window. So the time window is the upper end. Then we have the window size, how far back, and the binning information, how much aggregation should be done. And with this approach, you can really say the customer can choose any that point in time if he moves the upper limit somewhere on the time scale, and we can give back that information. And the functionality to implement is where the value timestamp between upper end minus the time span of the window size to the upper end. And with that, you have always that window that you are looking for. And then filling the gaps. The first moment, it sounds extremely simple. That's what I showed in the high-level presentation. As soon as you are doing binning, it is getting a little bit more complicated. Because if you have a bin, you have several data points in that bin. And how should you then give the end user the binning calculation? If it is, in quote, traditional data, you probably do an average. In my stock use case, we said if we have missing data points, we do a fill forward. because the last known value is the one which is relevant, which means if we are doing binning, also the last known value is the one that we should expose and not the min, max or average. We have really to find that data point, and which means we have to divide the data set into the slices where we would like to do the binning, and then find within each of the slices what was the latest data point, and then show to the end user this one. Luckily, it is also not very complicated in KQL to define it. We can just use the corresponding values and feed it back. So this is at the end the whole story. We give back in the binning the max value timestamp that we have in these window sizes, and the min one that we can say, well, the data that we are giving back is coming somewhere from that window. And then we have the minimum one that we have, the average one, the maximum one, and the really important one where we really find out the latest data point in that window. And then to calculate the corresponding gain and loss is again simple stuff. And with that, we are at the end. We have again the possibility to make the whole solution a little bit more simple to visualize with these, how they are called? Task flows. We show them in action, and next steps that we plan is to add, for example, data activator, because it is possible that you say, well, if this stock is growing that fast, I would react on it. And then the system will control these data sets over the time. We already migrated SQL to single fabric. We should update the PowerPoints. We should write blog posts about the solution. We already implemented GitHub. We already implemented the possibility to build the metadata using really a warehouse and leveraging the new accelerated shortcuts, which haven't been in place there. And I believe we have also on the backlog to use the event streams instead of feeding the data directly there. But we can come to the conclusion. And the long version is here. The short version was my triangle in the morning. Yeah.
Okay. Perhaps as a recap. Please.
We see here the code to find out the latest data points. You can see on that timeline we don't have any gaps in it, which means we have to fill the gaps before. And in the morning, when we saw the energy consumption over the week, because we have late arriving facts going back months, we cannot calculate what the consumption was. We can just store at this point in time, the meter told me it's 100. At some point later, he told me it's 120. If in between there are holes, we have to do a linear fill over these holes. And then we can do a calculation. What is the difference between these data points? Which mean when Lionel clicked on a city, we went through all the timelines belonging to that city. We created a list of data points that we should have. We found out where are the gaps. We filled it linear. And then we calculated the difference between the data points. And then we summed it up over the timelines. and it was a click, and 3 seconds later we had the result. So it is impressive how much logic you can implement, and the system is capable to deal on top of such time series. And the same is true here. The first part is fill the gaps, then do the binning, then find the right data points and give the bin value back.
Right, thanks. Then conclusion. Here we are. Our goal was, as mentioned, to do everything with Microsoft Fabric. And I think now we achieved it, as we have as well the SQL database, and we really could leverage the full potential of this unified platform that we really pitch and talk about it. And one of the most, let's say, nice things or features which are not so obvious perhaps is we haven't spent a second talking about any kind of network security, permission, whatever kind of thing during the project, because everything is unified, everything is there, everything is already connected to each other. And you see, we haven't stored anywhere any kind of credentials. Yes, we created connections, obviously, but to be able that the notebook writes into an event house and so on, it's just one single line of code to create an access token. So that was really, really nice. And even if it sounded from the beginning easy, like, hey, I want to get some data and analyze it, we realized during the project from a technical point of view, it's probably not that easy, because we have data factory, we have notebooks, we have a lakehouse, we have even a SQL database, we have Custo, we have Power BI. And with that, we have all different kind of languages coming from Python to SQL to KQL to DAX to M to what I'm missing to, you know, whatever. So understanding JSON, understanding Panda, the data frame. So it's not that easy. And it's really necessary to have as well the technology side, that you have people who can do so. And we do not believe that there is one single person who can do everything. And if so, I would like to meet him or her. That's the reason why also we teamed up. And I think it makes sense to have a team in such a case where you have this technology expertise. But besides the technology, you also need to have this domain expertise. In our case, stock information is quite easy to understand for everyone, I would say. You have a stock, you have a price, that's it, right? But nevertheless, it's also good to know in a real world when you're working with data that you have this domain expertise, knowing, hey, do you need to fill forward your data point? Do you need to have an average? Do you need to fill backwards, perhaps? So these kind of questions, this is domain expertise and not something that we from a technical point of view know. We know how to implement it, but we need as well the business saying us what they need at the end. And to sum it up, it's a collaboration work, and we had like weeks and months working on it. We started simply, and then you know how it is, it grows and grows over time, and we have many more ideas, but that's the beauty of it. I learned a lot from him regarding KQL, regarding data warehouse stuff. I wouldn't say the same the other way, but it was really great, and I'm really looking forward to enhance it in future with Mindrad. And most importantly, it's an iterative process, because you start, then you see, probably I can do it a little bit different. I can enhance it. I can do, you know, really iteratively working on it. And I think with that, we really come to the end of the presentation. I just want to show you one last thing, because I talked a lot about it, and I want to prove it to you. We tested the performance, how fast it is. And the left table shows me the upper visual, the right table shows me the down visual. And we run it against the cold cache and the warm cache. Cold cache means it really goes back to Custo, takes the data and brings it back to Power BI. Warm cache means if I already have the result asked once, it will take it from the cache of Power BI. This is at the end what it means. And what's for me super, super interesting is that in some cases, I am faster with KQL. Where is it? It's always nice if I don't see it. Okay, but one of the most important thing is that even the warm cache and the cold cache is no big difference. And if I go on the second slide, I think it's over here, that with in some cases I was really faster over here with connecting to Custo than by calling the same from the warm cache of Power BI. So this shows really how fast this engine is when it comes to such kind of data. This is at the end what we wanted to show here. Yes. ADX. ADX is Azure Data Explorer. It's at the end a standalone Azure service, which is Custo, which is Event House just as a standalone. And probably from 5 years, did we had signups 5 years ago? Yeah.
SQL database. ADX Data Factory SQL database. Power BI. Power BI. And yeah, the most important one. lot of money, lot of time. Networking guys who understand how to connect it, and a secret store. Key vault and handling this key vault stuff. So I would say the work plus 30% overhead just to do plumbing.
To give you an idea, we worked on it, I would say like 40 hours together, more or less over the last few months. Additionally, we had like 25, 30 hours to create a GitHub repo, but the solution itself took us like 40 hours. And if you would do it with signups like he explained, I'm sure 15, 20 hours more would be spent just for networking and security related topics, when not even more. I'm 100% sure. Okay, for those online, the question was how would we evolve the solution if you want to forecast, for example. I'm not sure if, just a second, from my point of view as Python, I would do most likely a notebook connecting to the lakehouse. In this case, using the data and do a forecast on that. But I don't know if you have a better answer for that.
I would write the KQL statement. I would write the KQL statement to do the forecasting. If this one here. Exactly. So this is the real one, and this is the blue one is the forecast. So you have already in KQL forecast algorithm. If they are good enough, I would use them. If they are not good enough, you can add maybe Onyx models or your own machine learning model, and then run queries against the data estate and use your machine learning model to do the prediction. And then the question is coming how to present it. This is an option. The new dashboard, our real-time dashboard is an option, and a notebook is a very good one. Mm-hmm. And I believe there's a solution somewhere in between. If you create that function, if you connect your Power BI dataset to that function, then you can provide from a business perspective the slice parameters that should be applied to fetch the data. And then you can use an Excel add-in which connects to the semantic model, which gives you just back the result that you are slicing. This helps sometime. I hope the integration will be improved there. But that's the way how it should be. No. It's above you see that the code that is necessary. This makes it here. Series, decompose, forecast, and you can specify parameters. So it's a standard forecast library which is able to use seasonality. You can already see it here. So we have probably a weak pattern here, which is behind that data set. And also anomaly detection, the sample that I showed, where the system gives you back, we believe here is something going crazy. And I believe we also release now a service where the system is capable to monitor multiple data streams and detect if they usually have some kind of a correlation. And if this correlation changes, that it tells you, well, I believe there's something new. In the past, if the temperature was higher, the energy consumption was also growing, and suddenly I see there a different behavior that we can then dig into the data. The definition there is on high granular data. And you have also a lot of functionality to do text search, reg expression, stuff like that. So to analyze log and telemetry data, there is also very useful. And that's the place where the engine itself is born. So it's the engine that we use to monitor Power BI, to monitor Office 365 and Azure. And for me, it is important to know because the better that engine works, the more money we earn. Because we get from you, you pay an Azure subscription, you consume a service. We have to do monitoring. Each dollar that we spend for that monitoring engine is going away from our net profit. So it's our deepest intent to make that engine as fast, as optimal as possible. Mhm. The red one. The automatic way is the red one. So, and you can just replicate tables. So if you replicate data, if you have duplicate events in your time series, you replicate duplicate events because it's at the table. It's not necessarily the JSON that you got, but after the transformation, you can say, okay, please replicate that table. But then but we have data factory, for example, a pipeline where you can put that statement in your pipeline, run it once a day, and then you have another table in one lake which has current date with a forecast for whatever you do. At the same point in time, yes. But 2 seconds later, no. That's the problem of snapshotting. Well, you can do that. Yes. Yeah. shirt or bottle.
For those who missed it, I mean, you can also create, as we learned, a function. You can create a policy on the table once the data arrives that you call the function to execute this forecast, save it into a different table, and the table can then be replicated into the lakehouse. This would be like more easier, more automatic. Anything else? Any other question? Talking with Meinrad. No. Naming conventions. Yeah. Yes, we are both perfectionists, I would say, and this is a nice way of pointing to each other's errors. Like, you know, I would do it differently, and we both know that we would, but it's always it takes time. Yes, it's not consistent. Yeah. It's still today, it's not 100% consistent. Unfortunately, it bothers us both, but it takes time to do that. I wouldn't say we had big issues because it's a try and error, and every time it errors, luckily either him or me knew what was wrong, so we could work around with it because we had the technical expertise, I would say. So the biggest thing, or Copilot, yes, or really Copilot helped us a lot in coding because it's much easier to say, give me code and you get it instead of writing it on your own. You're just faster, that's the thing. But for us, I think the biggest issue that we had is time. Yeah, because we really had to have time to work on it. And with such kind of things, you cannot just work half an hour. You really need to focus on it and have like half-day days, which is quite hard, honestly, in the last few weeks and months. But that's a different story. Yeah.
Because it's that close to many customer use cases. We have had also the chance to say, okay, for that customer project, we implement that piece with customer structures. And then we said, okay, and in our environment, the table is now called XYZ. And both way, I was also able to go to customers and say, well, I have here something that works. Can we apply it to your case?
And just to show you something really, oh, sorry. We had the solution ready. And in the last few days, while creating the solution, you see how many updates we had. You know, so this just shows we really wanted to make it as perfect as possible, but obviously it doesn't work 100%, as naming convention and some stuff are still there, which we need to update. Did you want to show here something? Yes, I know what you mean.
That's with shortcuts. If you created the shortcut from Fabric, from Event House, the first time it was called customer, then you dropped it, then you recreated it, then it was customer 1. And we already have created functions on top of it, which was a bug. And in the meantime, it is fixed, but that was something that made us a little bit crazy.
Yes, please. Very good question. Yes, I will. I just realized I don't have a URL for that. The question was, how can I subscribe to the user group? The easiest is if you go to aka.ms/fabric UG for user group. And if you go there, you will be redirected to the official Microsoft Fabric user group Switzerland. And this is where I announce the topics, the next events, and so on. So what I would recommend is, for sure, create a user here and register. The next thing, follow me on LinkedIn, because on LinkedIn I also posted, and the user group runs usually every first Thursday of the month from 5 till 6:30. So, and I do the latest and greatest, the first 20 minutes. And then we have a session like today where we talk about different kind of things. It could be anything from, hey, I have a cool report, to deep tech like today. And if you wish to receive an invite, a calendar invite, unfortunately, the website do not provide that. I know that we're going to update the website soon. Until then, you can write me a mail or LinkedIn or whatever. Just provide me your mail and I will put you into the distribution list as I created a blocker for the user group. So that's how it would work. Thanks. No, no good solution for sharing the slide deck, unfortunately. As internally, I'm not allowed to create an Azure Blob Storage with a public link. So I cannot put it on OneDrive and share it publicly as well. It's restricted internally. On the user group itself is also not the best. So we're thinking of ways. Yeah, we'll find a way at some point in time for sure. And for those who don't know, we have as well a YouTube channel where we put on the recording. So if you miss a user group, you can always go to the YouTube channel. At the end, it's quite simple. You go to aka.ms/fabricug YouTube and you get there. That's it. Anything else? All right, then with that, just two more words. One is the next user group will happen next month, but not on the 1st of May. I don't know for you guys, but I will not work on the 1st of May. So we just skip it for 1 week. It will happen on the 8th of May. It's not in person, that's my fault. It will be online, remote, so not here in the rooms. It will be online. We haven't defined the agenda yet, but I think we will do more deep dive into the announcements of what during the FabCon. So what's happening this week, I guess it will take quite a long time there. But if you are interested in presenting any kind of cool thing that you wish to share, feel free to reach out to me. Happy to have you and to give you a slot to present to the user group. And with that, thank you very much for staying so long. We overshoot a little bit just by 25 minutes. So thank you for that. I hope it was useful. I hope it was an interesting day. And thank you, Meinrad, once more. Pleasure. Pleasure. Thanks.